Hi, my name is Shubhika and today I'll introduce our work on mask selection and propagation for unsupervised video object segmentation. Our aim is that given only a video sequence as input, we're supposed to generate segmentation masks for objects and then track them throughout the video. The set of objects should contain at least the objects that are likely to capture human attention throughout the whole video. The previous work in this field deals with either single or multifocal object segmentation. In single object segmentation, only one mask is generated for all foreground objects. These approaches cannot directly be integrated in a multi-object scenario as they do not have to tackle the challenges in tracking. In multi-object scenario, either mask Gaussian masks are used for segmentation and temporal information is not used, or they do not include ways to reduce the propagation error of mask Gaussian masks. In this work, we've built upon a semi-supervised method called space-time memory networks. Moving to the solution pipeline, it consists of three stages. The first stage involves generation of object mask from mask Gaussian for all frames in a video. The second stage involves propagation of previous mask using STM, online selection for better masks from current STM mask and the mask Gaussian mask, and addition of new objects. The last stage includes offline selection of the best of the two masks generated in the previous stage using two different criteria. In the first stage, to initialize STM, we use the first frame from mask Gaussian as the ground truth annotation. The challenges include that not all objects are present in the first frame, and masks from mask Gaussian are noisier compared to the actual ground truth. This results in unsatisfactory propagation. A solution to deal with the above problem of missing object is to add new objects with the help of mask Gaussian mask. To deal with the noise in the mask as they propagated along, we employ selection criteria to choose better masks. Stage 2 tackles online mask selection at each time step to propagate more accurate masks ahead and reduce the noise in them. To do that, at every time step, we take the current STM and mask Gaussian output. Then, a bipartite matching is done between the objects from both the output. The mask from mask Gaussian now contains some masks which are associated with STM mask and some new object mask. The associated mask undergo a selection process using two different criteria, and a better mask is chosen and propagated ahead. Finally, new objects are added. This step at the end reduces two different outputs using two different criteria. After the completion of stage 2 for the whole video, we then use an ensemble of the two previously generated results to capture the best of the two results. The selection for the better mask in stage 3 is done using criteria 1. Now, for criteria 1, we train and employ a neural net which we call a selector net. The aim of this net is given two segmentation masks of the same object, choose the mask which is more accurate. The criteria 2 involves choosing the mask which has lesser change in area compared to the mask of the same object in the previous frame. The aim of selector net is given two segmentation masks of the same object. It has to choose a mask which is a better representation of the object. It consists of a feature extractor backbone which is given a 4-channel input containing the RGB image on the mask. The features from these two masks are then concatenated to predict the final score using softmax loss. The mask having a higher score is then chosen as the better mask. The table shows here the quantitative results on Davis 2019 test challenge dataset. We achieve a state-of-the-art performance with JNF mean of 61.6%. Here are some quantitative results on Davis dataset. It can be seen that depending only on mask Gaussian mask for every frame is not correct as they're very noisy. This example shows how online selection of mask results in better mask propagation as compared to using only STM on the first frame. This slide shows the result at different stages and helps understand how we are able to deal with recovery of objects, which makes our algorithm robust to failure cases of one criteria. These are some more results on SecTrack V2 and FPMS dataset.